The June 2025 conflict redefined asymmetric warfare forever. Faced with overwhelming American technology, Iran relied on precision missiles, swarm drones, and strategic deterrence. This video documents every single weapon system Iran has prepared to target United States forces. Let's begin with the ballistic missile arsenal. Short-range ballistic missiles, Fattah 110. Considered the tactical backbone of Iran's missile force, this weapon served as the foundation for an entire family of precision-guided systems. It featured solid fuel propulsion, which allowed for rapid deployment and shoot-and-scoot tactics, keeping launchers safe from counter-battery fire. While early versions lacked accuracy, later generations integrated GPS guidance and reduced the circular error probable to 100 meters, transforming it from a terror weapon into a battlefield asset. Fattah 313. The evolutionary step forward in the Fattah lineage. This missile extended operational reach to 500 kilometers while drastically improving precision. It featured advanced composite materials and a guidance suite that achieved a circular error probable of just 10 to 30 meters, accurate enough to strike specific aircraft shelters. While still limited to regional targets, it provided Iran with the ability to hit U.S. bases across the Persian Gulf from deep within Iranian territory, enhancing launcher survivability. Zulfiqar, Iran's combat-proven precision strike weapon, fielded extensively during the 2020 Al-Assad airbase strikes against American forces. It featured a separating warhead design which discarded the spent booster body during terminal phase, reducing radar cross-section and increasing velocity. While liquid-fueled systems require preparation time, the Zulfiqar demonstrated pinpoint accuracy against hardened targets, hitting specific hangars and proving Iran's shift from area bombardment to surgical strikes. Desful, the bridge between short and medium-range classifications, pushing tactical missiles into strategic territory. It featured a 1,000-kilometer range while maintaining the same mobile launch footprint as shorter-range systems, allowing deep strikes without requiring larger, more vulnerable launchers. While bridging capability gaps, it provided Iran with options to strike targets across the entire Middle East, from protected launch sites within Iranian borders. Rayad 500. Iran's demonstration of advanced material science, utilizing composite technology to reduce weight and signature. It featured a carbon fiber composite motor casing, branded Zohair, which made the missile lighter than the Fattah 110 while achieving equal 500-kilometer range. While representing incremental range improvement, it showcased Iran's ability to integrate cutting-edge materials into mass-producible weapons, reducing both radar signature and production costs. Qiyam-1, a radical redesign of Cold War-era Scud technology, stripping away conventional aerodynamic surfaces. It featured a finless design relying entirely on thrust vector control for stability and guidance, reducing radar cross-section during the vulnerable ascent phase. While liquid-fueled systems are operationally demanding, the Qiyam separating reentry vehicle and maneuverable warhead variant proved highly effective during the Al-Assad strikes, demonstrating reliability under combat conditions. Next on the list are the medium-range ballistic missiles. Shahed 3, Iran's first true strategic ballistic missile, derived from North Korean technology. It featured a 1,300-kilometer range that finally gave Iran the ability to hold distant adversaries at risk, representing a strategic breakthrough for Tehran. While plagued by poor accuracy with a 2,000-meter circular error, probable and slow liquid fueling requirements, it established the foundation for an entire generation of improved medium-range systems. Ghadr 110, the improved successor to the Shahed, featuring aerodynamic refinements and faster deployment. It featured a distinctive baby bottle nose cone designed for higher re-entry speeds and improved terminal stability, extending range to nearly 2,000 kilometers. While still requiring liquid fuel, encapsulated fuel tanks and advanced inhibitors reduced launch preparation time to under 30 minutes, dramatically improving survivability against preemptive strikes targeting launch sites. Imad, Iran's precision revolution in strategic missiles, marking the transition from counter-value to counter-force capability. It featured Iran's first functioning maneuverable re-entry vehicle with aerodynamic fins allowing trajectory control after atmospheric re-entry, reducing circular error probable to under 500 meters. While the missile still uses liquid fuel, its precision transformed medium-range missiles from city destroyers into weapons capable of targeting specific radar sites and air defense batteries, as demonstrated during the 2024 and 2025 exchanges. Shahed-2, arguably Iran's most survivable strategic asset, combining solid fuel responsiveness with medium-range reach. It featured a two-stage solid fuel design that comes factory-sealed and ready to fire, allowing launch within minutes of the firing order without vulnerable fueling operations. While production numbers remain limited, its Mach 12 to 14 terminal velocity compresses engagement windows for endo-atmospheric interceptors, and its rapid launch cycle makes preemptive destruction nearly impossible. Khorramshahr-4, also known as K-Bar, Iran's heavy payload platform derived from North Korean Musudan technology. It featured a massive 1,500 kilogram warhead capacity, or alternatively, the potential for multiple re-entry vehicles, giving Iran options for overwhelming defenses or striking multiple targets from a single launch. While liquid-fueled and operationally complex, hypergolic propellants allow the missile to remain fueled for years, and with lighter payloads, range potentially extends to 3,000 kilometers, approaching intermediate-range ballistic missile classification. Next on the list are the hypersonic missiles. Fattah 1. Iran's first operational hypersonic weapon, specifically engineered to defeat exo-atmospheric interceptors. It featured a spherical solid-fuel engine with a movable nozzle on its second stage, enabling thrust vectoring outside the atmosphere for erratic mid-course maneuvers that complicate trajectory prediction. While claims of Mach 13 to 15 terminal speeds remain debated, its unpredictable flight path forces missile defense systems to expend multiple interceptors per target, and combat data from 2025 suggest it successfully stressed engagement timelines. Fattah 2. The liquid-fueled evolution featuring a hypersonic glide vehicle as its second stage. It featured sustained aerodynamic maneuvering capability within the atmosphere, functioning as a high-speed maneuverable re-entry vehicle rather than a traditional ballistic warhead. While not a scramjet-powered cruise missile, Iranian doctrine employs it specifically to target anti-ballistic missile radars and batteries, using unpredictability to penetrate defensive bubbles and clear paths for follow-on strikes by less sophisticated missiles. Next on the list are the unmanned aerial systems. Shahed 136, known in Russian service as Geran 2. Considered the defining export of Iran's military-industrial complex, this delta-wing loitering munition has been used extensively by Russian forces in Ukraine and Iranian proxies across the Middle East. It featured a 2,500-kilometer range, commercial GPS guidance with anti-jamming CRPA antenna technology, and a 50-kilogram warhead, all for an estimated production cost of just $20,000 to $50,000 per unit. While individually unsophisticated, swarm attacks force defenders to expend interceptors costing millions, imposing a devastating cost curve and validating Iran's asymmetric warfare doctrine. Shahed 131, known as Geran 1, the smaller sibling in the Shahed family, optimized for shorter-range missions. It featured a 900-kilometer range with a compact 15-kilogram warhead and a distinctive Wankel engine, making it ideal for probing air defenses and revealing radar positions. While carrying less explosive power, it often operates as the first wave in mixed strike packages, drawing fire and exposing defensive systems for follow-on attacks by heavier ballistic missiles or larger drones. Shahed 101, the silent evolution in the Shahed lineage, purpose-built for stealth penetration. It featured a compact electric or quiet engine propulsion system, producing minimal acoustic signature, making it nearly impossible to detect by sound until impact, unlike the distinctive moped noise of the Shahed 136. While details remain scarce, it was used in the lethal Tower 22 attack in Jordan that killed 3 U.S. service members. demonstrating how low-signature drones can bypass sophisticated base defenses through stealth rather than saturation. Shahed 238, the jet-powered variant designed to defeat gun-based counter-UAS systems. It featured high subsonic speed and an electro-optical terminal seeker for engaging moving targets, making it significantly harder to intercept with anti-aircraft guns like the Gepard. While more expensive than propeller-driven variants, its speed forces defenders to use man-portable air defense systems or advanced missiles, maintaining the cost exchange advantage that defines Iranian drone doctrine. Hadid 110, also known as Dalahu, Iran's jet-powered stealth suicide drone, designed specifically to penetrate modern integrated air defenses. It featured a faceted low-observable airframe, reducing radar cross-section, jet propulsion enabling 510 km/h speed, and a 30-kilogram warhead for destroying high-value point targets. While carrying a smaller payload than the Shahed 136, its high speed and reduced signature create compressed reaction windows for point defense systems, making it a bunker buster for enemy radar installations. Next on the list are the intelligence and strike platforms. Shahed 129, Iran's medium-altitude long-endurance workhorse, functionally similar to the American MQ-1 Predator. It featured the ability to carry 4 Sadid 345 precision-guided bombs, up to 24 hours of endurance, and comprehensive ISR sensor packages for regional intelligence gathering. While lacking the sophistication of Western platforms, it provided Iran and its proxies with persistent strike and surveillance capability, serving as the backbone for tactical reconnaissance operations across the Middle East. Shahed 149, designated Gaza, the high-altitude long-endurance evolution, comparable to the American MQ-9 Reaper. It featured a 21-meter wingspan, 2,500-kilometer range, internal payload bay for reduced radar signature, and capacity for up to 13 precision-guided munitions. While production numbers remain limited, it represents Iran's move toward more sophisticated reusable combat drones with electronic intelligence pods, demonstrating ambitions beyond disposable kamikaze systems. Shahed 191, also known as Saigeh-2, the stealth penetrator based on reverse engineering the American RQ-170 Sentinel, captured in 2011. It featured a flying wing design with internal weapons bays for reduced radar cross-section, jet propulsion for higher speed, and the ability to carry precision-guided glide bombs. While its true stealth characteristics remain debated, it launched from vehicle-mounted racks for high mobility and represented Iran's most ambitious attempt at building a penetrating strike platform for missions in denied airspace. Next on the list are the naval asymmetric systems. Ghadir-class midget submarines. Considered the workhorses of Iran's littoral submarine fleet, these vessels serve as ambush predators in the acoustically complex Persian Gulf. They featured a 120-ton displacement optimized for shallow water operations, 2 533mm torpedo tubes, mine-laying capability, and the ability to bottom by resting on the seabed, rendering them nearly undetectable. While limited in endurance and range, intelligence suggests a fleet of 14 to 23 units capable of wolfpack tactics, exploiting the geographical constraints where large American nuclear submarines operate at a severe disadvantage. Fattah-class submarines, Iran's indigenous semi-heavy submarine design, bridging the gap between coastal and ocean-going capability. They featured 600-ton displacement, capacity for torpedoes, mines, and submarine-launched cruise missiles like the JASC-2, and greater endurance than the Ghadir class. While still optimized for littoral operations, they provided Iran with expanded operational reach beyond the immediate Persian Gulf, allowing longer patrols and heavier payloads for strikes against surface vessels. Hoot torpedo, Iran's supercavitating anti-ship weapon, reverse-engineered from the Soviet VA-111 Shakval. It featured speeds exceeding 200 knots, approximately 370 kilometers per hour, achieved through creating a gas bubble around the torpedo to dramatically reduce water friction. While unguided or wire-guided with limited maneuverability, Its extreme speed renders traditional acoustic decoys and evasive maneuvers completely ineffective. And at close range in the confined Strait of Hormuz, target vessels have mere seconds to react before impact designed to break the keel of aircraft carriers or destroyers. Next on the list are the surface swarm assets. Unlike conventional naval vessels that engage at range, these fast attack craft were designed specifically for overwhelming American Aegis combat systems through sheer numbers, attacking simultaneously from multiple vectors to saturate defensive channels. Zulfiqar-class fast attack craft, based on the British Blade Runner 51. Considered the speed demons of Iran's swarm navy, these vessels serve as the primary platform for small boat saturation attacks. They featured speeds up to 70 knots, variants carrying Nasr-1 anti-ship cruise missiles or light torpedoes, and extreme maneuverability, allowing rapid closure to target vessels. While individually vulnerable, doctrine calls for deploying hundreds simultaneously from multiple vectors, overwhelming the target acquisition channels of Aegis combat systems and close-in weapon systems to ensure enough survive to deliver crippling blows. Zulfiqar-class air defense variant, a recent innovation adding anti-air capability to the swarm fleet. It featured vertical launch systems for Nawab short-range air defense missiles, specifically designed to accompany attack swarms and provide cover against American AH-64 Apache helicopters. While representing a small portion of the fleet, these vessels address the primary counter to small boat attacks, forcing U.S. forces to engage the swarm with ship-based weapons, rather than relying on airborne suppression. Next on the list are the naval mine systems. Maham-2 Bottom Influence Mine, Iran's sophisticated smart mine, optimized for anti-submarine and anti-surface warfare in shallow choke points. It featured acoustic and magnetic sensors for target detection, a 350-kilogram warhead, and crucially, ship-counting logic, allowing it to ignore escorts and minesweepers before detonating under high-value targets like tankers or aircraft carriers. While designed for depths of 10 to 50 meters, intelligence from July 2025 confirmed Iran practiced loading these weapons onto vessels during tensions, demonstrating readiness to execute the strategic blockade that defines their naval doctrine. Sadaf-2 Moored Contact Mine, the simpler, more numerous component of Iran's mine arsenal, optimized for creating defensive barriers in shallow waters. It featured traditional contact detonation, requiring physical impact, allowing deployment in massive quantities to saturate choke points. While less sophisticated than influence mines, sheer numbers create dense minefields requiring extensive clearance operations, and the combination of contact and influence mines forces minesweepers to conduct slow, methodical sweeps under constant threat from other Iranian systems. Next on the list are the air defense systems. Bavar 373 Long-Range Surface-to-Air Missile System, Iran's indigenous answer to Russian S-300 and S-400 technology, developed after delivery delays forced self-reliance. It featured the Shahed 4B missile, with claimed engagement ranges up to 300 kilometers, altitude ceiling of 27 kilometers, and an active electronically scanned array radar, purportedly capable of detecting stealth aircraft. While its actual performance against F-35s remains debated and unproven in combat, the system creates denial bubbles that force American support assets to operate at extended ranges, degrading overall strike effectiveness, even if direct shootdowns prove elusive.